Hello everyone, and welcome to another episode of Fun with Gen AI. In today's episode, I will be doing something similar as in the previous episode. So this episode will actually be about RAGs. Yeah, and RAGs are retrieved augmented generation. You can go into the previous episode too if you want to hear more about RAGs. In this episode, I will expect that you have went through previous episode and you know what RAGs are. And in the previous episode, we discussed RAGs where we used Azure AI services to do to represent the vector database and to do embeddings. And in this episode, we're going to go one step further or nearer, if you like, and we're going to have these components of RAG, so vector database and the embedding model locally. So still the process is the same, and in here you can see the process. So actually there, as I said, two distinct processes. One process is when the user asks a question and then wants an answer, and then you can see that when the user asks a question, the question is then embedded, and then vector search is performed with this embedded question in mind. Top K chunks are retrieved. Prompt is now combined with chunks given to OpenAI. So we still use Azure OpenAI, and Azure OpenAI gives us an answer. But there is then another flow that is the pipeline, the ingestion pipeline for the documents. So there is a document, the document is processed, chunked, each content is hashed, and then if the chunk exists, we just skip it. If the chunk doesn't exist, we generate embedding and index. Now, this was actually example for the previous. This is a mermaid diagram for a previous video, but it's still valid. But now we will be indexing this not in Azure AI Search. We'll be indexing this into our local vector database. So from Azure, we just need then the LLM, and just for that, because I did not present it in the previous video, if you go into models, any of your normal models will just do as an LLM, and that's it. But for our embeddings, as I said, we're not going to use Azure. We're going to use models from Hugging Face. Hugging Face is, in a sense, a marketplace for LLMs, embedding models for a lot of different models, and you can find and use models from there locally. So because I'm on a Mac machine behind a corporate firewall, I decided to use Infloat E5 Small V2 model, and I use it through the Docker. So I think we should be able to see it here. Let's see. No, this is a sentence. Okay, well, I will show you how I actually use when we go to the code. But we use this model for our embeddings, and you can find it here, text embeddings inference. So it actually, then to be more precise, this is text embeddings. So there are other types of embeddings. We're just using this as text embeddings. Okay, so let us now go into the code to see how this works in Python. Okay, now this is an example of a Python application that is similar like a chatbot, but it uses local embeddings and local vector database. You can see on the left, it has very similar components, but now instead of embedding, there is local embedding. There is a vector DB, which in the previous video was the indexer. chunk text for X is the same. So chunking is the same. And we have the reg pipeline in here that actually just combines all these things together. Now, before we go actually how the pipeline works, just continue with this, and this is actually the command line to run the Docker. Actually, not to run just Docker, but to run this model. So we decided to use this model in float e5 small v2 as our embeddings model. This command actually just makes a local server on this port and runs this on Docker, and then we can use it. We can connect to it and use it. So this is for our embedding. And for our vector database, we use the so-called FICE database. And this database is a local database. It just sits on our local computer and can, let's say, index chunks, and it can also search them. Now you may ask, okay, well, like, what is the difference between this database and the Azure search, for example? Well, there are also many different databases. This is just one option. And if you want to do this in production, you will have to check the other databases and check what is the best option for you, and like the speed, the efficiency, the size of the documents that can come in, all of that you will have to investigate. For the example purpose, this is enough, but for the real production, probably it could be, but probably you will have to investigate more and maybe use some other vector database. For example, also big companies like Postgres and MongoDB, they also provide vector databases that you can use that are then more enterprise oriented. Okay, so that is that. Then local embedding just calls this just the way to approach the local embed is just a post request on the port, and then it just you get the embedding. So it is that simple, and this is just a wrapper around that. And then in the pipeline, well, again, there are two modes: interactive mode where the user discusses with the system, and a non-interactive mode where the documents are chunked and embedded. So this is the interactive mode. So the user types in, the user gets a query. What is your question? The user says, okay, I want to know this and this and this. And if the user says, I want to exit, we just exits. But otherwise, there is this answer question for this user input. And the answer question is similar to the previous one. So the vector database is loaded. Then the query is performed based on the user query on this vector database. Then a vector of up to 10 elements is retrieved. So actually, for first the user query is embedded. The user query is embedded. And then this is the query vector is the first element of this query response. And then based on this query vector, the vector database is queried, and these are the results, the at most k chunks, where k is 10. And if there is no information, then it just says, well, there is no information, and it stops. Otherwise, the prompt is built from the results, from then these are the chunks, and from the user query, and then the Azure is called with this prompt, with this messages prompt, and then returns the normal LLM response. So that is it. Nothing really complex. There is a lot of code here, but in general, it's a very, very simple system and very simple idea. And let's just go one test. Again, this is the same model. So underwriting, what is this underwriting? Now this will give me response. Yeah. And the response now is using the documentation that we gave it. I didn't like if I would have given the information that the LLM should take these chunks, and if I would give information about the chunks themselves in the context, then the Gen AI, the LLM would bring back a more grounded result. But if I say, yeah, I ask another question about football, and then the chunks don't have anything about this. So this is now second example of Rex. If you want to know more about how it is done through Azure itself, you can check my previous recording. There is another option to actually improve the results that LLM gives, and that is fine tuning. And I believe I will be talking about fine tuning more in one of the future videos. For now, thank you for listening, and goodbye.